We are asked to calculate the empirical or molecular formula mass and the molar mass of each of the following compounds. So what we want to do here is calculate the molar mass. And this molecule cannot be simplified anymore. There's a 1 for the coefficient of calcium, a 1 for the coefficient of carbon, and a 3 for the coefficient of oxygen. So this is already the empirical formula. It's the same as the molecular formula. And let's go ahead and calculate the molar mass of this compound. So I'm using the average atomic masses from ptable.com. For the element calcium, we have one of those, and it has an average atomic mass of 40.078. Okay, grams per mole. And remember, molar mass is the mass of 1 mole of your substance. Carbon has, there's one of those, has average atomic weight of 12.011. And oxygen, since we have 3 of those, has an average atomic weight of 15.999. So on our calculator here, we will calculate the contribution of oxygen towards the formula mass. Now, once we find out all the masses of all the different elements, we add them all up together. And we get about 100. So this is the molar mass of the compound, okay? And that has units of grams per mole. For part B, we have sodium chloride. And this is quite simple. I mean, there's one sodium. And sodium has an average atomic mass of 22.990 grams per mole. Chlorine is 35.45. And again, I'm using the numbers found on ptable.com. It's a nice periodic table you could print for yourself. Now we add up these two numbers and we get the average, we get the formula mass or the molar mass in units of grams per mole. Okay. For part C, these are very large molecules, perhaps of interest to a geologist. So we've got beryllium, and we have 3 of those. And you need to find that on your periodic table. That's element number 4. And beryllium has an average atomic mass of 9.0122. And again, I'm using the numbers off of ptable.com to calculate all of these. The next element is aluminium. It sounds weird, but that's actually the name for what we would call aluminum here in the United States. So we have 2 of these in the formula, and aluminium's average atomic mass is 26.982. And so on our calculator, we want to write down the mass from this. And we have silicon. We have 6 of those. And each silicon has an average atomic mass of 28.085. Okay. So we want to multiply these out to figure out the mass contribution of silicon. And the last element here is oxygen, and we have quite a few of those, 18. Okay. And that comes out to be 287.982. Now the last step to figure out the molar mass is to add up all of these. So let's go ahead and do that. Okay, and I get 537.4926 grams per mole. Okay. For D, we have malachite. This is a green, turquoise kind of colored thing. But anyways, we have two coppers, so two coppers in the formula. And copper is element number 29. All right, and we'll go ahead and do that. Now for oxygen, you have to be careful here. There's technically a 1 for a subscript next to this oxygen, and the 2 in the parentheses there causes that oxygen to be 2 here. But there's also 3 over here, so there's a total of 5 oxygens in this formula. And so 2 from the hydroxide and 3 from the carbonate gives a 5 total. So let's multiply this out. Okay. The next element we could look at is hydrogen. And remember that if you have a parenthesis of 2, it means 2 of whatever's inside of the parentheses. And we have hydrogen, right, with technically a subscript of 1. So there's 2 hydrogens in that. Okay. And we have 1 carbon, so this C is carbon. This C is part of the Cu. So we have just 1 carbon. And we have, well, we already counted the oxygens up here. So the last step here is to sum up all of the contributions from all of the elements. And the grand total here is 221.1185 grams per mole for malachite. Okay. Turquoise is also a bluish green colored compound because of the copper element in there, the copper ion. So this is crazy formula. So if you can do this, you can pretty much tackle anything. So first of all, let's count up the different elements in here. We have 1 copper ion. It's not within a parentheses, and there's no coefficient. So copper is element number 29. It has an average atomic mass of 63.546. And I'm using the numbers from the ptable.com. You can print out your own periodic table there. For aluminium, we have 6 of those elements. So if you find aluminium, notice how it's spelled aluminium. It has an average atomic mass of 26.982. So let's compute that now. Okay, next let's do phosphorus. Now you have this formula PO4 and then parentheses of 4. Now remember that the subscript that isn't shown there is technically a 1, and the 4 here means that we have 4 of whatever is inside the parentheses. So that's equal to 4 phosphates within the compound here. So we have 4 phosphates, okay, and each phosphate has an average atomic weight of 30.974. So we'll calculate that now. and we get 123.896. All right. Now let's figure out how many oxygens there are. And we have three different things to think about. All right, we have PO4 with a 4. As I mentioned, we have 4 of the phosphates. So 4 times 4 is 16. Okay, 16 oxygens from this part. We have OH 8. Remember, there's a 1 for the oxygen that's not shown. So 8 times 1 is equal to 8. And then we have H2O4. Okay, and there's a 1 not shown for that subscript. So 1 times 4 is equal to 4. Okay, so there's quite a few oxygens there. 16 from the phosphate, 8 from the hydroxide, and 4 from the water. And that gives you a grand total of 28 oxygens. Okay, so 16 plus 8 plus 4. Each oxygen has an average atomic mass of 15.999. So let's compute the contribution there. And that's 447.972. Okay, the next element we want to think about is hydrogen. Okay, and let's look again to see where they're located. So we have 8 hydroxides, and there's a 1 not shown there for the subscript for the H. So 8 times 1 is 8, so there's 8 hydrogens from that. And then we have H2O in parentheses 4. So the 2 there is multiplied by 4. Kind of like if you had 4 bicycles, you would have 8 wheels. So here we have 8 hydrogens as well. So we have a total of 16 hydrogens in this humongous molecule. And we multiply that by the average atomic mass of hydrogen that you find on your periodic table. And we get 16.128. Now the last step always is to add all of these up, okay? And that will give us the grand total that we're interested in. Okay, so hopefully you understand the concept from all of this, and watch out for those parentheses, and it's convenient to combine elements so you only have to do the calculation once. Molar mass has units of grams per mole, and thanks for watching, and please consider subscribing.